Alright, so once you get the printer turned on and you've got it connected to your network, just go to the IP address in your web browser and it'll bring up the Duet web interface. It'll bring up, this is the screen you're going to see when you log in. It'll be the main screen, the machine control screen. I do want to go ahead and say this is an older version of the firmware. I think the layout is a little bit easier to use. If you want to upgrade the firmware, you can. But for these tutorial videos, I'm going to be using the slightly older firmware. It still has a lot of good features, but just letting you guys know that this is just the older version, an older version of the firmware. A newer version of the firmware has an updated interface, and I can show you what the updated interface looks like. This it's a lot more sleek looking, but I don't know, for the sake of this video, we're just going to use the old interface just because it's a lot easier for me navigating right now. Alright, so this is the main screen, the machine control screen. Hitting the home all button will home the printer. And the job status, this is when you're running a print. All the information will be on this screen, and this area is important right here, the Z baby stepping. Your G-code files go in here, and you can upload G-code files directly from your computer. Just browse to them, and so let's go ahead and we're gonna upload this. This is on the hard drive on my PC. Hit open. So it's gonna upload it over the Wi-Fi network to the Duet control board, to the onboard SD card. That way, once you start a print, you can shut your computer down and the print will continue because it's reading the print from the SD card. And that's what it's doing right now. It's uploading that file to the SD card. So this is on the SD card on the controller. And I just want to reiterate that the control of the printer and everything, once it's running a print, it's not dependent on the web interface. The web interface is just a control interface. It's an interface just to control the printer. It does not control the printer. It's basically the controller on the printer acts like a server, and we're just logging into the server. And then the settings tab, the system editor tab under settings is where you're going to want to go to make any firmware changes to the printer. And config G, this is the main configuration for the printer settings and everything. It's super easy to edit. Everything is in G codes. That might be a little confusing to some of you. Maybe come from some old school Marlin, or if any of you have ever dealt with SmoothieWare, that was a big SmoothieWare guy, and this was way different to me when I started using Duet controllers. I really like this now. I think it's the easiest controller to edit and understand, in my opinion. Again, it's all in one file. It's not all spread out into a bunch of different branches or anything like Marlin is. Marlin's great, but the Duet interface and everything is just way easier to edit. So, and we're going to be spending a little bit of time in here doing the initial calibration. Just a couple of settings that we're going to have to change, nothing too hard. So every time you make a change in here, you're going to want to click Save Changes, and it's going to prompt you to reboot the board. We're not going to do that because I didn't make any changes. And then another thing to note is, so say you start a print, you're printing, and in the G-code console, like you want to change the acceleration or any kind of setting on the fly, change the setting, send it, you're happy with that setting, and you're running a print, and you notice some positive changes in the print, and you want to go ahead and make those changes to the config so you don't forget to make those changes later, but you're running a print. You can go ahead and make those changes in the config and hit save, and it will not reboot, but it will save those changes, so when you turn the printer off and turn it back on after you finish that print, those changes are going to be permanent. You've already sent them through the console, so they're going to take effect through the rest of the print, but next time you reboot the printer, they're already going to be set in the config. And that's just one thing that I thought was really cool, is you can make changes to this while you're doing a print, and it will not reboot the board and pause the print. All right, so let's actually start doing some initial calibration on the Ultimate XL. Alright, so first thing you're going to want to do is home the printer. Not yet. Actually, just to be safe, what you want to do is you want to go over to the G-code console. Don't move anything yet. You want to manually put all of the axes in the center of their travel, and send a G92, X50, Y50, Z50. Oops. That would be Z50. What this does is it tells the printer that these axes are at 50 millimeters of travel within their travel. So we're sending this code, and you'll notice up here, the printer thinks it's at X50, Y50, and Z50. This way we can manually jog the printer to make sure all of the direction is correct. So X+1 should move in the X positive direction. Let's check that right now. It does. We'll do it 10. Good. Y positive 10 should move the bed towards the front of the printer. And it does. And then Z+5 should move the Z-axis up. And it does. Alright, so we're good. We can hit home all. Excellent. Alright, now the printer is homed. So let's heat the bed up, because we're going to do some initial calibration. Let's just go ahead and take it to 60C, hit enter. Again, this is on the machine control page. And the bed is going to take a while to heat up, and you might think that that is not good, but remember the thermistor in the bed, I put it on the edge of the bed, so the temperature reading on the display is the actual temperature of pretty close to the whole bed. A lot of people think SSRs, or silicone heaters, AC silicone heaters, heat up the bed fast. Yes, they do, but a lot of people don't realize is a lot of those silicone heaters have the thermistor inside in the center of that silicone pad, and that's just not representative of the whole bed temperature. The thermistor that's mounted in the center of that pad is being heated directly by the element inside the pad. So what I do is I mount the thermistors on the edge of the bed. So you might think that's a little slow to heat up, but it's really not, and it's actually a closer representation of the surface of your printing surface temperature. So once that gets up to temperature, and let's go ahead and heat the nozzle up to, let's do 220. Let's calibrate it for PLA. And then once that gets up to temperature, we can jog it down to the bed and set our initial Z height. Come on. We can go ahead and get it pretty close to the bed. So there's two ways you can manually enter G-code. You can do it up here, quick and easy, or you can do it through the G-code console. I like to do it through the G-code console because it will keep a log of all the commands you sent, and I think it'll do it too if you do it here. So let's just do a G90 and let's see if it logs. Okay, yeah, cool. So let's go ahead and position the nozzle 50 millimeters from the bed. So that's G0 for rapid movement, Z50, and it's going to move the nozzle down to roughly where it thinks it's 50 millimeters above the bed. Alright, so we're getting pretty close. So now we're 50. We're good. We're still quite a bit away from the bed. So I'm just going to go ahead and do a Z20, get a little bit closer. Alright, that's good. Now I'm going to start manually jogging down. I'm going to do, let's see here. Okay. And the 0.5 millimeter movements. And I'm getting down just to where I can see. So you can do the paper method. I don't do the paper method. I just actually eyeball it. But you want to jog it down to where you see just a little bit of a gap, a tiny amount of gap. The paper method would probably be best for you to do. I eyeball it. So yeah, just go ahead and do the paper method. I can see a little gap, and sure enough, I'm at Z0, so that's great. So this is not great for your first time calibration because this printer has been assembled before, and hang on a second. That's not. I'll be damned. That is Z0. Huh. Even after tearing the printer down and rebuilding it, Z0 is still in the same spot. Alright, so say it was, I don't know, half a millimeter. Like you're doing the paper test, and you've dogged it down, and the paper's dragging, and it's half a millimeter. Well, that's our Z0, but the controller thinks it's 0.5 millimeters. So we want this to be Z0. So we go into settings, config. Remember we were at half a millimeter. Go down to your M208, your max travel, and we're going to edit the Z max setting. So this printer homes at Z max. So what that means is the printer homes at the top or maximum travel of the axis. So when the printer homes, it loads this number into the controller. So when the Z-axis homes, this is the position the Z-axis is in, and that's correct. The Z would be at 271.53 millimeters above the bed. We never ever change our Z minimum. The Z minimum is negative half a millimeter to allow for travel past 0 for this initial calibration procedure. So if we were short, this gives us some buffer to jog the axis down past 0 to get true calibration. We never want to deal or edit the Z min. Only if we cannot calibrate our Z height do we edit the Z min. Our Z0 is always edited via Z max because our printer homes the Z axis to the max location of the Z axis. So remember, we were half a millimeter above the bed, or the controller thinks we're at half a millimeter, but we're really at 0. So what we're going to do is, so we're half a millimeter, we want to take away half a millimeter of travel from the Z axis. Because if we go to Z0, we're going to be crashing into the bed. So what we're doing is we're taking half a millimeter out of the travel of the Z max. So remember, it was originally at 271.53. Well, that's too much travel to the bed. So we're just going to take half a millimeter out of it. Hit save. Reboot yes. Wait for the printer to reboot. It will disconnect. Give it some time to refresh. There we go. Home the printer again. Go ahead and reheat the nozzle and reheat the bed because we rebooted. Now we go to our G-code console. Type in a G90 for absolute coordinates just to be safe, and G0, we're just going to go ahead and go to Z0. Let's check. Alright, so you do the paper drag test again at your Z0. You're happy, you're good. If you needed to make any more changes, then you would come back to here and make your changes. I do. Actually, 0.53 was perfect. I rebooted, waiting for the interface to refresh. Here we go. Alright, so we've done our initial calibration. We want the nozzle to cool down now because we're about to probe the bed. We don't need the nozzle to be hot when we probe the bed, but we do want the bed to be hot. So we're going to heat the bed back up, and let's go ahead and turn on our tool fan to help cool that nozzle down, and do a visual inspection of the printer to make sure the part cooling fans are on, and also make sure that the hot end heatsink fan is on as well. The hot end heatsink fan, it comes on when the hot end reaches 40°C. So again, going back to calibrating the initial Z0. Oh, and we are still at, okay, we rebooted. Let's go ahead and home. Okay, great. Yeah, see, that's that 271.53. Let's go into our config. See, it matches. So you gotta do some math when your initial calibration. You might be short or over when you're calibrating that initial Z height. So if you were, half a millimeter, you did the paper drag test, and the interface is saying that you're at half a millimeter. You want to take half a millimeter out of the Z travel. But if you're, say, at negative half a millimeter when you do the paper drag test, and the paper's dragging at negative 0.5 millimeters, you want to add half a millimeter, or whatever that number is, to the Z max. The Z max is also, we're also going to tune the Z max when we're setting our probe height and everything. I know that sounds a little confusing right now, but it's going to make sense later. This is just initial calibration so we can start probing the bed. When we print, we're going to be printing using the G29 grid strategy, and we're going to be loading a grid that we probed. And tuning this number is going to help us get around how the Duet documentation has you tuned the probe height. It's a lot easier to tune your Zmax setting than it is to tune the probe offset. But we do have to tune the probe offset initially. So we set our hard Z0 at the bed. Now we want to calibrate the probe offset. Let's go back to machine control. All right. So our nozzle, we're at 70°C. Let it cool down a little bit, because when we're probing the bed, we kind of want the nozzle to be cold or at room temperature, because as the nozzle cools down, it's going to contract and it's going to throw our probe off, our grid off. So we really want to wait for this number to get down probably to like 40°C or so. And it probably would help if you take off the silicone sock while it's cooling down. And, well, it's off. So So we're going to connect the probe. And the probe is connected with, it'll all be in a bag. 2M3 by 8 screws, not 6. And the probe is connected. You're going to see it. It's right on the bottom of the extruder setup. You're going to thread these screws in to the mount, and then you're going to use the screw that's right above the probe to preload against the nozzle. So this screw right here is the preload. Make sure it's bottomed out before you install the probe, and the probe just gets screwed into under here. So once you have that probe screwed on, use this screw to preload it against the nozzle. As soon as it starts touching the nozzle, back it off. Or I'm sorry, it gets preloaded against the heater block. As soon as you start to see this screw push down on the mount, alright, so that's good. So now it's preloaded. Good. And then plug it in to the side through the PCB cover. That cutout is exactly above the in line with the Z probe connector. And then test the Z probe. Make sure it's reading 1,000. It is. Alright, so our Z probe is connected. And we're going to go ahead and hit Calibrate Z probe height. It's going to home the printer. And remember, our bed's hot, but our nozzle's cold. Alright, so the Z probe just hit the bed. Let's remember this number, 66.4. Alright, and this macro is going to probe the bed a couple of times. It's going to go up to 80. Come back down. Remember that number, 66.41, I think. This macro might be... Well... Oh. Let's just go ahead and edit this macro real quick. Okay. That should be, yeah, that's good. Okay. That will be taken care of when you get the printer. You will not have to edit that macro. Okay, so remember, let's calibrate Z probe. Alright, the probe hit at 66.41. It gives you time to write that number down. Okay, now it goes back up. Alright, 66.41 again. Alright, so remember that number, 66.41. We're going to leave the probe connected and everything, and we're just going to go into config G. We're going to come down to Z probe section, and the G31, remember that number was 66.41, so this is where we change it, 66.41. This is our probe offset. We click Save Changes. Yes, reboot. There we go. Alright, so now we're about to probe the bed grid. Make sure we heat the bed, because we rebooted, it set the bed back to 0. It's active. Okay, good. We're going to home all. And our probe's still connected. We didn't disconnect our probe. Now we're going to click Probe Grid. Probe Bed Grid. Alright, so once it finishes... Ooh, alright, so this... Oh boy. So it's exaggerated. So we need to adjust our X and Y. Because that first point is way too high. Alright, so let's physically check the bed and see. Oh, okay. Yep. There was a little nub from where the nozzle was resting on the bed, because that nozzle's had plastic through it before, and some of that plastic got on the bed. Okay, so let's go ahead and reprobe the bed. You won't have to do this, but I'm gonna go ahead and reprobe my bed, and then through the magic of editing, I'm just gonna warp you to the end results. Okay, much better. So yeah, it doesn't look great, but this is way exaggerated. I've seen worse grids that I still get really good prints from. So don't be too worried if this doesn't look. It obviously doesn't look perfectly flat, but trust me, it's okay. If during our first layer test we notice any issues, we can go and we can realign the x-axis. But what this is really showing us is actually the warp of the bed. So yeah, it's a Mic 6 heat bed, but that Mic 6 still warps a little bit, and that's just showing us proof that how sensitive that probe is. So that's good. So don't worry if your height map looks more like a draped cloth than a flat surface. Trust me, it's okay. Alright, so that almost concludes the initial calibration. The last thing we need to do is run a test print. So disconnect and take the probe off now before you forget, and crash it into the bed when you go to do your first print. Okay, we got the probe off. Let's load in some filament. So we're going to load PLA. I suggest you load some PLA in yourself, because you're going to actually need to print some parts for the printer. Lucky you. So, But first we're going to do the first layer test. I can delete. Oh shit. Nope. I can delete that. We don't need that. And there's going to be another file on here, and it's going to be in the end caps. You're going to have to print the end caps. It'll print the whole set of end caps and a little alignment tool, and the end caps get super glued onto the end of the extrusion. And when you get done printing those end caps, sand the flat surface of the end cap so the glue can really bite onto that. Okay, so our nozzle's getting pretty close to temp. Let's go ahead and put the spool holder, actually install the spool holder onto the printer and load in some PLA. But before we do that, we want to turn the extruder motor off so we can manually feed some filament through. And this is for the Bondtech BMG guys, the first rounders. Everybody else gets the Hemera, and with the Hemera, your configuration is going to have a load and unload filament macros. I do not make load and unload macros for the BMG because you can manually do it, and do not make an unload macro for the Bondtech BMG. I repeat, do not do that. It will clog and it will be such a pain in the ass. You will be kicking yourself for trying to think that you could figure out how to make an unload macro. I've been down that road. It is not worth it. I will show you how to easily unload filament out of the Bondtech BMG, but please don't make a macro that unloads filament. You'll definitely regret it. Alright, so let's get that spool holder on and load some PLA. The spool holder. Oh, shit. There it is. So the spool holder goes onto side of the printer. There's 2 tap holes on the side. Slide it up with those tap holes, and boom, goes on, easy peasy. Put your probe up in a safe spot, because you'll rarely ever use it again. We're going to load some Pit Daddy Gold PLA filament, of course, because why not? Alright. So disconnect the feed tube, or actually no, leave it connected. You can leave the feed tube connected and feed it through the bottom of the feed tube. Alright, so once the filament gets to the extruder, take your hand down at the bottom and kind of put some pressure on it and onto the tube and manually feed that Bondtech gear. And so what we're going to do now is we're actually going to set the tension on the Bondtech idler. So a few turns in, and we're going to feed it down. Remember, we set the nozzle to 220. We're going to feed it down. This nozzle's already been used somewhat once. So what I'm doing is the idler's kind of loose right now, and I'm doing some hard pushes on it, and I can feel it slip. So I'll tighten it a little bit more. No more slip, and so I just tighten it a little bit more. What you want to do is when it slips no more, when you give it some hard pushes, still kind of slipping, let's tighten it a little bit more. Still kind of slipping, a little bit more. That should be good right there. Do not over tighten this on the Bondtech B&G. Do not over tighten this. You can get it too tight and warp the filament. Better to have it, you want just enough grip to drive the filament. That's it. I'll go ahead and let's go ahead and unload the filament for the Bondtech B&G. So you're gonna unload some filament. Your hot end's heated up. Pull the feed tube out. Trim it. Don't unscrew it, but release the tension like that. Just push it to the side. Push the filament down until you see some come out of the nozzle, and then yank it out real quick. That's the surefire, sure-proof way to never get a clog when unloading filament. If you make a macro, well, I can't help you. Because you're going to be getting those flesh cutters up inside the Bondtech if you make a macro to unload filament. Alright, so let's do a test print. And there's already a print on the Duet that I want you to do, and that's the first layer test. First and foremost, clean your bed off. And I like to clean my bed at temperature with alcohol. I've noticed if you clean the bed when it's cold, the alcohol kind of leaves, I think it's the water and the alcohol kind of leaves a residue behind. So, as I was saying before my SD card filled up, I always clean the bed at temperature with alcohol because it doesn't leave as much of a residue. Alright, so we're ready to do our first test print, and that is the first layer test. And so you're going to be playing around with the Z baby off step, or the Z baby stepping when the first layer test is going on. So let's go ahead. We've got filament loaded. We're at temperature, so let's go ahead and run this first layer test. And actually, no, I know I'm going to be already close to the bed, so I'm just going to go ahead and bump it up a millimeter. And if it's doing some moves and buffering some G code, it's going to save that in the buffer. So don't go crazy hitting this button just yet. Wait till it starts laying down some filament, and then you can hit it, and it'll increment. I know I'm going to be way close to the bed. Come on. All right. Yep, too close. That looks good at 0.4. So really, this outer perimeter isn't really going to tell you much. When it starts laying down the solid infill is when you're really going to start tuning things. The reason I went ahead and went up to 0.4 is because what you didn't see is I already did this test, but the microphone wasn't on, so I'm actually redoing it now. Alright, so once it starts doing the solid infill, then you can start tuning this. You do not want to smash a really smashed first layer on this this PEI, especially its top grade CS hide PEI. It sticks really good to PLA. So the old trope of you really want that first layer nice and smashed, that's not true. You actually kind of want it not to where it's just barely touching, but a little bit below that, maybe, I don't know, 75 microns or so. I don't know, that sounds a little bit confusing. You just kind of have to get a feel for it. So if you bump it up, and then you're going to start seeing those infill lines. You're going to start seeing some separation in between them. Then start bumping it back down until that separation disappears. So bump it up, you'll see that there's some empty negative space in between those infill lines, and then bump it down until that negative space goes away. That looks good. Let's one more just to be safe down. Alright, so I'm pretty happy with that. You can go ahead and let the print finish to see if you've got a uniform level grid. I'm just going to let this one go maybe to halfway. But yeah, you can run this test, and it's just going to lay a first layer down over the entire print area. And it's really... So this initial first layer calibration print is to calibrate the final Z height, and then to test for a level grid. Okay, but for the sake of this video, okay, so see, my Z baby stepping is at 0.35. That means I had to bump it up. I had to raise the nozzle 0.35 millimeters from 0. So what that means is, so everything we've done in this video so far, you will only have to do once. You won't have to do it before every print. You won't have to do it once a week. You can do it maybe once a month, or anytime that you feel like you need to reprobe the bed. But this does not have to be done before each print. That probe, let me show you real quick, hang on. So that probe grid that we just probed earlier, it's saved on the SD card. Where is it? See right here, height map.csv. It's gonna pull. This is our bed grid, and it's gonna pull this bed grid up before each print, and that is in your start G code. That is a G29S1 will load this grid before each print. And you can always come in here and click on the height map, and if you click on it, it's just gonna load it up as a visual representation. Look at our beautiful draped cloth printing surface. But it's flat, trust me, it'll print nice and even. Okay, so where was I? Alright. So 0.35 millimeters. We're gonna take that number and we're gonna go into config G. Now this is where we get around the Duet documentation of having to calibrate the probe offset number. Duet documentation wants you to continually adjust the probe offset and then reprobe the bed. We don't need to reprobe the bed. We already have our bed grid. What we're doing here is we're taking that virtual bed grid that we're printing on, that bed plane, and we're moving it along the z-axis to where we want to put it. So we're just taking that bed plane and we're manually moving it through this method. We're not going to reprobe the bed. We're not going to adjust the probe offsets and continuously reprobe the bed and then do a first layer test and make sure our probe offset's good. That's just bullshit. We don't have to do that. We have already probed the grid. Adjusting the probe offset isn't going to change that grid that we're printing on. Adjusting the probe offset is going to move that grid, but that's just a long way to do it. The easiest way to do it is just we're gonna edit this, our Z-Max. We're gonna, in a roundabout way, we're forcing the printer to move our bed grid on the z-axis to where we want it. So remember, my Z-Baby stepping number is 0.35 for this print, and it's right here. I had to move the nozzle up 0.35 millimeters above the bed to get a good, consistent first layer that I'm happy with. So we take that 0.35 number and we're going to subtract 0.35 from this number. So what that's going to do is that's going to hard set the travel for our z-axis. So we're telling the printer, even before it loads the grid, we're going to go ahead and take off 0.35 millimeters from this number. So we don't have to. So this way we get around from adjusting the probe offset. Again, the Ultimate XL, the way I do things, these printers are built so well that you don't need to probe the bed continuously before each print. It's literally almost honestly a one-time thing. Yeah, you spent like it's a $40 probe that really gets used only once. I mean, yeah, you can probe the bed as many times as you want, but you don't have to. All right, so rambling on too much here. All right, 0.35. We raise the nozzle up 0.35. That means we have 0.35 millimeters too much travel in our z-axis, and we want to take that out. So, since I'm so good at doing math off the top of my head, let's get out the calculator. So we do 271.53, and we want to subtract 0.35 millimeters from our travel. So minus 0.35. 271.3 minus 0. So that comes out to 271.18. Again, you can save these changes while you're doing a print. And it saved it. Alright. So I was positive 0.3. I had to raise the nozzle 0.35 millimeters. Well, what if you had to lower it 0.35 millimeters? That means we need to add 0.35 millimeters to travel of our z-axis. So instead of subtracting, so if this was a negative, think of it like this. If your baby stepping is a positive, you subtract from your z-max. If your baby stepping is a negative, you add to your z-max. So if this was a positive 0.35, we would have if this was a negative 0.35, we would add it to our Z-max because we want to add 0.35 millimeters into the distance that the nozzle travels down to 0, which is our bed, the surface of our bed. And to get even more confusing, it's not really the surface of our bed, but it's where we want to print on. It's where we're happy with first layers. So that's good. All right, so we edited that number. I'm going to pause the print. I'm going to cancel it. The printer is going to move to its safe position. I'm just going to home it. So we updated that config, but that setting, I didn't put that setting into the G-code console because I want to go ahead and hard set it. So I'm going to go ahead and reset the printer to make those changes that we just did to the config take effect. And we're gonna run that first layer test again, but we're not gonna have to touch the baby stepping. Okay, so we rebooted. Okay, yeah, 60, and I'm just gonna go ahead and get the nozzle back up. Okay, so you're gonna want to take the flex plate off of the bed, but do not rip the print off of the bed while it's hot. You always want to cool the flex plate down before you take a print off, and the easiest way to do that is to take the flex plate off of the printer with the print still attached if it's still hot, and put it down on a cool surface, keeping pressure on the print onto the bed, onto that flex plate. So you've taken the flex plate off the printer, it's hot, with the print on the flex plate, and you want to put that flex plate down on a cool surface, keeping pressure down on the print. That way it keeps the flex plate nice and flat against that cool surface, and you're going to rapidly cool the surface of the PEI down. If you remove a print from the PEI while the flex plate is still hot, you're going to damage the PEI. You're going to take up, I don't really know what it is, but it's almost like you take up micro layers of the PEI and you damage it. And that's just not good because the print is still adhered to the surface of that PLA or that PEI. You always want to take the prints off of the flex plate with the surface cold. So I'm going to do that right now. Okay, before I take this print off, I'm just going to show you, hopefully this shows up pretty good. So you can see where I was adjusting it through here, and then I settled around 0.35 baby stepping in here, and that feels great. It's flat. I don't feel any like little bumps or anything that it was too close to the bed. It feels all nice and even, and you can see there's no separation there. And this is the bottom side, and it's nice and even. And then I usually just take a razor blade and take the purge line off. A razor blade is going to be your best friend. If you're new to 3D printing, or if you've never used one before, I use it all the time. Nozzle was too close there. Alright. Alright, so we just got our greasy little fingerprints all over the bed. That means we got to clean it again. That's hot at temperature. Okay, so we've made our final calibration adjustments to our config using our baby stepping number that we got from that first layer test, and now we're just going to do that test again just to double check that everything is good. First layer test. Bam. Okay, so we should be good. I'm honestly, I would go on about my day from here on out and start running some prints and stuff. You will notice that some instances you'll have to change the baby stepping, and if you notice, like over time, like hey, I'm usually, adjusting the baby stepping to positive point, 0.05 or whatever. But if you notice, you kind of sometimes have to adjust the baby stepping, and it usually comes around to the same number. Just take that number and edit the config again. And you should be good to go. But this should get you really, really close to consistent first layers. You're not going to have to reprobe the bed. If you notice some first layer inconsistencies, you too far or you too close to the bed, it's usually because the homing position just kind of slightly drifts a little bit. But just come in here and edit the config if you notice, that you're constantly having to adjust the baby stepping. You shouldn't really be adjusting this number. Now, if you're printing some PETG or some other filament that's got to be farther or closer from the bed, and you really kind of want to get around that in the slicer settings, well, yeah, you can do it right here. So PETG, do not print PETG to PEI. Certain PETGs you can get away with doing that, like the cheap Amazon or whatever PETG, but just always print PETG on like a sacrificial surface. But carbon fiber PETG, yeah, you can definitely print it directly to PEI. The carbon fiber in that PETG does something to it to where it doesn't bond to the PEI. That's just a little note in case you wanted to go crazy printing PETG to this PEI. Do not do that. It will bond. But carbon fiber PETG, yeah, you can print it all day long. I like the atomic filament carbon fiber PETG. That's all the carbon fiber PETG parts in this kit are printed with that atomic filament. Alright, so we're doing the first layer test again, and I did not touch my baby stepping. It's still at 0. And you're going to see that it's perfect. The first layer is now perfect. And it is. It's perfect. Alright, so that concludes the initial... That's it. The printer's ready to go. You can print your little heart out now. I'm just going to reiterate this, probably way too much, but I have gotten a lot of questions and a lot of emails of people curious about the way I set up the bed probing and if they have to do that before each print. The community is so used to having to probe the beds on these cheaper printers before each print and just continually make minute adjustments, maybe hardware adjustments to the bed mounting hardware or probing adjustments, and basically the mindset is that automatic bed leveling means you got to probe the bed continually before each print. No, you don't. You do not have to do that with this kit. It's one and done. That's a battle I've been fighting with the community. It's really hard to break that habit of just the normal mindset that's just how things are. Well, that's not how it is for this printer. I do things differently. I home to the max of the Z-axis. No other i3 machines do that. I don't know why. After a print, you can the NG code for the Prusa slicer that I'm going to send you. You're going to get a configuration for. The NG code is a G28. It homes the printer. On other printers, on other i3 style printers, well, homing the Z-axis homes to the Z-min. That would crash the print, but not on this printer, not on the Ultimate XL, not on how I set them up. It homes the printer to the Z-max, and that's just, it's safe to do it that way. That's how things are done in the machine tool industry. The CNC machines always home to the Z-max, and they always move the Z-axis first. Anyways, I'm rambling on here. The point is, that's it. You're done. You can go. You can print. Please email me if you have any questions. I'm sure there's going to be a few questions. I'm going to try to make maybe a couple more videos on some general operation tips for the Ultimate XL. And trying to think before I wrap this up if there's anything else you might need to know. I'm sure there is. I just can't think of it right now. You might have to make some adjustments to the I'm gonna send everybody a Prusa Slicer config. I really like Prusa Slicer. If you're a Simplify 3D user, I continue profiles for Simplify 3D. I used to be a really hardcore Simplify 3D user, but now Prusa Slicer has. I've gone to the dark side with Prusa Slicer. It's way better on the automatic supports and everything, and just the print quality. Just the way it handles certain things a little bit differently. I really like. Yeah, so you're going to get a Prusa Slicer config. Go ahead and tune those profiles to your liking if you're pretty good at tuning. I'm honestly not that great at tuning profiles. So yeah. And if you're not familiar with Prusa Slicer, I could, if you want me to do a video on it, I can. I'm not the best at using it. I was a Simplify 3D user for many years. I just started using Prusa Slicer a few months ago. But yeah, alright, so look for that config in an email, again, and look for the instruction manual. It might be, you're going to have to use that instruction manual to go along with the assembly video and everything. But yeah, this should get you up and going. You should be ready to use the printer now. But yeah, alright, thanks everybody. And if you have any questions, please let me know.